So, welcome to Jumbo IS and welcome to our lecture series called Daily News in Shorts. In this lecture series, we cover a particular day's newspaper or current affairs in a very short span of time within 20 minutes. The purpose of this lecture series is very simple. We want you to cover your current affairs on a daily basis. And why do we want so? Because current affairs form a very important portion for your UPSC examination as well as state civil services examination. If you are an aspirant of civil services examination, well, current affairs are of extreme importance for you guys. And you cannot feel confident for your current affairs portion if you're not covering current affairs on a daily basis. Okay, covering current affairs daily is very important if you are to clear this exam. All right. So through this lecture series, we are going to make sure that you cover your current affairs on a daily basis, and we are also going to make sure that you don't spend much time on current affairs because you have to cover other subjects as well, right? So we don't want you to waste your time. We don't want you to waste your entire day covering current affairs. Therefore, all we want is that you just spend 20 minutes or around 20 minutes on current affairs. And you should not feel that you have missed out on any of the important current affairs from the newspaper. Okay? That is why every day I shortlist important news items from the newspaper and I shortlist them from the perspective of them featuring in the civil services examination. Okay? The shortlisting part is done by me. Discussion part will be done by me. All you have to do is spend 20 minutes with me and you would have covered your current affairs for that day. So today we are going to be covering October 8th, 2024's current affairs. And the important news items that featured in this day's newspaper are as following. So in total, we are going to focus on these four topics. Okay, number one is Nobel Prize in Physiology or for the field of medicine. Nobel Prize for the field of medicine was announced. So we'll discuss about this Nobel Prize. We'll discuss about its significance. Then we'll shift our focus to Marburg virus because this virus is actually wreaking havoc in Africa. So it is infecting many people and it has caused many deaths in Africa. It is a dangerous virus. We'll talk about Marburg virus. Then third topic is bilateral investment treaty because recently India and UAE actually negotiated a bilateral investment treaty. So we'll talk about India UAE's bilateral investment treaty. We'll talk about BITs in general. How does government of India use BITs to encourage FDI in India? We'll talk about everything. Okay? And in the end, we'll shift our focus again to Nobel Prize, but this time in the field of physics. Okay? So we are going to be covering these four topics. Let's not waste any more time. Let's straight away jump into the discussion, starting with topic number one, which is Nobel Prize in the field of physiology. Okay, so let's take a look at what was in the news. So Nobel Prize for Medicine or Physiology this year has been awarded to scientists Victor Ambros and Gary Ruvkun for the discovery of microRNA. Now, microRNA plays a crucial role in genes regulation or genes function, basically gene regulation. Now, you all know what genes are. You all know what DNA is, right? DNA is made up of genes. Now, genes are very important for all the bodily functions. Okay, all the physiological functions of human body. How tall will you be? What will be your skin color? What will be your hair type? How much strength will you have? Your hair type, your eye color, everything is determined or everything is mentioned in your DNA, in your genes. Okay, and microRNA, these tiny particles actually make sure how your genes function or they actually regulate the functioning of your genes. And their discovery makes us better understand the functioning of genes. Okay, and through genes, basically human body. So their discovery was quite significant, and that is why they were awarded this Nobel Prize in the field of medicine. Now, I'm sure that you might be thinking what gene regulation is. This question must be arising in your mind, right? And if it is not, then it should arise in your mind because you should be curious about this thing. What do I mean by gene regulation? And how is microRNA or how are microRNA particles crucial for gene regulation? Okay, so to understand the discovery in a better way, you need to be familiar with the concept of gene regulation. So let's talk about gene regulation. All right, okay. Now, as I've mentioned before, genes actually govern how your body will behave, how your body will function. Okay? Now, genes are in your DNA, and DNA is in the nucleus of every cell in your body. Okay. Now, we are multicellular organisms, right? So we have different types of cells. Human body has different types of cells. We have bone cells, we have skin cells, we have muscular cells, we have different types of cells. And each cell performs a specific different function. Okay? The functions performed by bone cells are different from the functions performed by skin cells, and so on and so forth, right? But nucleus is in all of the cells, and DNA is also in all of the cells. Now, some genes in your DNA govern your skin color, right? Some genes in your DNA govern skin type. Some genes in your DNA govern your height. Some genes govern in your DNA govern your hormones, right? So different genes in your DNA perform or activate different functions of your body. Make sense? But all these genes are in the nucleus of each and every cell. That means bone cell has a nucleus, and in that nucleus there is DNA which contains all genes. Like genes that govern skin color are also here, genes that govern height are also here, genes that govern hormones are also here. All genes are in all the nucleuses of all the cells. But these cells perform different functions. So what must happen? Because bone cells have nothing to do with skin color, right? Therefore, the genes related to skin color must be deactivated in bone cells, and genes related to growth must be activated in bone cells. Similarly, genes related to growth hormone or genes related to bone density must be deactivated in skin cells, whereas genes related to skin type and color must be activated in skin cells. Now, different genes must be activated and different genes must be deactivated in different cells for those cells to perform their specific function. Make sense? And this is known as gene regulation. And all of this is governed by microRNA. So basically, DNA contains all the information, and DNA releases RNA which performs or which communicates to the body to perform specific function, right? And microRNA plays a crucial role in activation and deactivation of different genes in different cell types, right? I hope you understood everything. I hope in brief you understood what do we mean by gene regulation. All right? And that is why the discovery of microRNA was very important, because before the discovery of microRNA in the 1990s, we were unaware of how does the body perform this function of gene regulation. How is gene regulation being or is taking place in human body. But through the discovery of microRNA, we are now aware. Okay? Discovery of microRNA. In 1960s, scientists found that specialized proteins called transcription factors could bind to specific regions of DNA and control which genetic messages were produced, which genes should be activated and which genes shouldn't be activated. So before 1993, scientists thought that these special proteins called transcription factors controlled gene regulation. And it was considered a done deal. All scientists agreed that yes, gene regulation is governed by transcription factors. But after the discovery of microRNA by these two scientists in 1993, a new understanding came about. And now, today, every scientist agrees that gene regulation is governed by microRNA. Okay, so that is how significant, or this is the significance of the discovery of microRNA. That's why some people said that their Nobel Prize is long overdue, because without them or without their discovery, we couldn't have understood our human body in a better way. Okay? All right. Now we are done with topic number one. Let's shift to topic number two, which is Marburg virus. Okay? Now, why was this in news? Deadly Marburg virus could overwhelm Rwanda. Rwanda is a almost Central African country. Rwanda's fragile healthcare system. Since the first Marburg case in Rwanda was detected last month, at least 46 individuals have been infected and 12 have died. So, in 1 month, 46 individuals have been infected with Marburg virus and 12 have died. Plus, 80% of the infections are among medical workers. So, doctors, staff of the hospitals are more at risk of this deadly virus than anyone else. Now, why is this and alarming news. Why is this a dangerous news? Because Marburg virus is very dangerous. Now, how dangerous is it? It is among the deadliest pathogens known to humans, with Marburg virus disease. Case fatality rates range from 24 to 88%. So, this is a virus that causes Marburg virus disease. And this is a very deadly disease because it has led to 24 to 88% mortality, which means that in the past, whenever this virus has caused any disease outbreak, in some places it has even led to 88% of mortality. That means of 100 people infected with this disease, 88 died. Now, that is a very dangerous mortality rate. That is why this is very dangerous. Now, this virus belongs to filovirus family like Ebola. So, Ebola was also very dangerous and had a high mortality rate. So, it belongs to the same family as Ebola. And why is it called Marburg virus? Because Marburg is a place in Germany. And this virus first infected humans in 1967 in Marburg, Germany. After that, it did not infect many people in Europe, but infected a lot of people in Africa. But the first outbreak was in Germany, and that is why it is called Marburg virus. Now, how does it spread? There are two ways of the transmission of this disease. Okay, there are two ways through which this disease spreads. One is indirect. Okay, so this virus infects bats. Okay, Rosetta's bats. Now, if you come in contact with these bats, you get this virus and you get infected. Okay, then there is direct, or we should call it human to human transmission. Okay. Now, if you come in contact with the bodily fluids like blood or other bodily fluids of an infected person, or you come in contact with a particular object that was contaminated with the bodily fluids of an infected person, you will catch this virus. So it spreads rapidly also. So it's a dangerous disease. Now, what is the treatment for this disease and how can we prevent it? And basically, what are the symptoms? Okay, so symptoms are high fever, severe headache, muscle ache, watery diarrhea, abdominal pain, cramping, vomiting. But in severe cases, it might lead to hemorrhagic symptoms, which might cause internal bleeding. Hemorrhaging means bleeding. Okay, and if this internal bleeding is very severe, it leads to death of a person. Now, incubation period for this virus is 2 to 21 days. What do we mean by incubation period? Time period between when you first contacted this virus, between infection and symptoms, first onset of symptoms. So you might get affected with this virus, and then your symptoms might start to show after 21 days. So the incubation period is 2 to 21 days. Sometimes it's 2 days, as low as 2 days. Sometimes it's as high as 21 days. So for 21 days, you don't even know that you're infected with this virus. Okay. Now, how to prevent this disease or treatment? Currently, there is no vaccine, approved vaccine for this virus. There is no treatment also. There is no antiviral drug that can kill this virus. There are only experimental vaccines. One is called Marburg vaccine that was created by Sabin Vaccine Institute. Okay. But WHO says that if someone is infected with this virus and if someone is suffering from MVD, then you should provide them with supportive care. Supportive care means if you have fever, you give them paracetamol tablets, you give them hydration fluids, okay, which improves symptoms and which improves the health of a person. But there is no drug, no medicine that will kill this virus. Okay, and there is no vaccine available as well, only experimental vaccines like Marburg virus vaccine. Okay, so that's about it. Now let's move on to our third news item, which is bilateral investment treaty. Now, why was this in news? In a move away from the model bilateral investment treaty, the union government has eased arbitration norms for UAE investors, the treaty next released on Monday showed. Now, India and UAE signed a bilateral investment treaty, which would govern which would have rules for foreign investment by UAE into India and foreign investment by India into UAE. Basically, it's a bilateral investment treaty. This treaty was signed in Abu Dhabi on February 13 and it came into force on August 31, 2024. Now, to understand this paragraph, basically what I said in this paragraph, you need to know what bilateral investment treaties are. Okay? So, first of all, what is a BIT? So, these are reciprocal agreements between two countries to promote and protect foreign private investments in each other territories. Okay? So, the thing is that let's suppose there is a company called Vodafone, which is let's suppose of England, and they invest heavily in India. Okay. Now let's suppose India makes certain rules that promotes Indian companies and discriminates against Vodafone. Now, in that case, Vodafone would feel that their interests are not being protected in India. Therefore, India is a bad country to invest in. Therefore, we shouldn't invest in India. And Vodafone would tell other foreign investors also to not invest in India because Indian government does not take care of foreign investors, does not protect foreign investors, and discriminates against foreign investors. There is a bias for domestic investors and not for foreign investors, right? Because India has no rules. So, therefore, to give a sense of predictability to foreign investors, to tell them that we would give them fair treatment, we would not discriminate against them, we would give them national treatment. National treatment is a principle of WTO, which means we would not discriminate against foreign investors, or we would treat them at par with domestic investors. Okay, national treatment clause. So, therefore, there was a need for, or there is a need for some rules and regulations which would regulate how foreign investors would be treated in India. And India might also have similar concerns in England. Various Indian investors like Tata, Ambani's, Adani's would feel the same in England. Therefore, to protect each other's investors in each other's countries, these two countries will sign BIT, Bilateral Investment Treaty, to promote and protect foreign private investments in each other territories. So basically, BIT establishes minimum rules or guarantees that each other's foreign investors would get. Okay. Plus, in case there is a dispute between Vodafone and Indian government, then BIT would also contain proper rules and regulations as to how these disputes would get resolved. Okay. If Vodafone has a dispute with the Indian tax department or Indian government, or Indian government has a dispute with Vodafone, how that dispute will be resolved would also be mentioned in BITs. So that is how significant BITs are, because BITs basically govern the investment situation or the investment regime in India or different countries. Okay. Now, India started BITs in 1994. The first BIT was signed with UK. Okay. And India basically created a model BIT. Okay. In 1993. So India created a model BIT in 1993. This model BIT would form the basis of all the BITs that India would negotiate with different countries. So this model BIT gave the base for all the BITs that India negotiated after 1993. Okay. But in 2000s and early 2000 and after 2010, India found out that their government is at a disadvantageous position because of the rules mentioned in Model BIT 1993. India lost a lot of cases against these multinational companies, and these multinational companies won many millions of dollars against India. India lost a lot of money. India lost many cases. Therefore, India decided that we should change our Model BIT, and that is why India came out with Model BIT 2016. After 2016 Model BIT, India changed certain rules in BIT so that those rules are more favorable towards Indian government in case there is a dispute between foreign investor and Indian government. And after coming out with Model BIT in 2016, India actually terminated 68 of the 74 BITs that were negotiated earlier. And India told all these countries that we are finishing the earlier BITs and we want you to sign new BITs, which would be based on 2016 model, so that our government doesn't lose, because India thought that 1993 model BIT was bad for it. Therefore, India finished all the other BITs that were based on 1993 BIT and asked the countries to negotiate new BITs based on 2016 model. All right. Now, 2016 model BIT was more in favor of Indian government and less in favor of the foreign investor. Okay. That's why many countries felt that, we shouldn't invest in India. Now, UAE also felt that as per the new model BIT, their foreign investors won't feel safe in India. Therefore, India negotiated a BIT with UAE in which India diluted some of the rules in the model BIT of 2016. India created a special case for UAE so that UAE investors feel safe in India. So that was in the news. Now you understand this paragraph? That's about it. All right. And last, which is Nobel Prize in Physics. Nobel Prize in Physics 2024 has been awarded to John Hopfield and Geoffrey Hinton. While Hopfield, 91 years of age, is an American scientist and has been long respected in the field of biological physics, British Canadian Hinton, 76, has been called the godfather of artificial intelligence. Now, as per the Nobel Prize's website, these two people have been awarded Nobel Prize in Physics because they use the concept of physics and made them applicable to the field of AI. It was their contribution that AI became such a big force in today's age. In fact, it is because of their contribution that we have large language models today. We have chat GPT today. We have deep learning today, machine learning today, because they adapted certain concepts of physics for in computers. Okay, and through their contribution, AI was born. This year's laureates used tools from physics to construct methods that help lay the foundation for today's powerful machine learning. Now, what was their contribution basically? To understand that, just hear me out first. First of all, what do you understand by the term artificial intelligence? What is artificial intelligence? What is AI? Machines that are intelligent, right? But how can you say whether a machine is intelligent or not? How do you define intelligence? So, what researchers did was they said that any machine that mimics human intelligence. So, if a machine mimics human intelligence, right, then we'll call it artificially intelligent machine. If a machine is able to replicate what human brain does, then we'll call that machine artificially intelligent machine or intelligent machine, right? Now, to make computers or to make machines mimic human intelligence, you have to mimic some aspects of human brain also, because our intelligence comes from our brain. Now, therefore, many scientists or many physicists started replicating our nervous system, how nerves in our brain are arranged. They started replicating, or they started copying that. They started copying human brain. They started copying our nervous system, our nerves, in the computers, and they created artificial neural networks, which is just a machine form of nervous system. And because of the discovery of artificial neural networks, now we are able to create models, AI models like ChatGPT, DALI, Zero One, Project Star, many other things, right? So, artificial neural networks were discovered because of the contributions by these two scientists. And through artificial neural networks, we were able to create AI as it is today. Okay. So a neural network is a method in artificial intelligence that teaches computers to process data in a way that is inspired by human brain. Okay. It is a type of machine learning process called deep learning that uses interconnected nodes. Like our human brain has interconnected neurons, they connected wires in that way, in a layered structure that resembles human brain. AI models today are based on artificial neural networks. All big AI models are based on artificial neural networks. Neural networks. And artificial neural networks were made possible by the discovery made by these two scientists or physicists. That's why they were awarded Nobel Prize in Physics. All right. And with that, we conclude today's session. Thank you so much for watching, everyone. And I'm sure it has added value to your preparation. But it would add more value if you are consistent and regular with this lecture series. And it would add even more value if you revise today's lecture also. And you can revise that from our PDF file. This PDF file will be available on our Telegram channel, and the link to our Telegram channel is provided in the comment section below. So make sure you click on the link, go to our Telegram channel, follow it, and download the PDF for not just this lecture, but all the other lectures featuring on our YouTube channel. All right. On that note, I'll be signing off. Thank you so much, everyone, and I'll see you next time with next day's current affairs. Thank you.